Hi, welcome back to Calculus. Today's lesson is the basic derivative rules. We're going to go over the rules, do some examples, and then do an example with a tangent line just to see how it all works. So there are lots of rules. There are like a bajillion rules. But what we're going to do here is just some basic ones. This is probably the most important one, the power rule. The derivative of x to the n is n x to the n minus 1. So that means the derivative of x squared is going to be 2x to the 1. That's how you do it. You take this number, you bring it down, one less. It applies to things that are not whole numbers. So the derivative of x to the 1/5 is going to be 1/5 x to the 1/5 minus 1. Now 1/5 minus 1 is negative 4/5. We'll do some examples and see how it all plays out in a second. These two rules are also important. They make derivatives a linear type operator. If you add two functions, the derivative is the same as adding their derivatives, subtracting the same. Notice this is adding and subtracting, not multiplying, not dividing. Those are special, they'll come later. If you multiply by a number, the derivative is just the number times the derivative of the original function. This is really important, and it makes a certain amount of sense. If you think about the derivative as the limit, and you put 2's in front of every one of the f's, you can factor that 2 out just here. Now, then some more specific ones. This is sort of an application of the previous rules, but if you have a line and you take its derivative, well, the derivative is the slope of the tangent line. So if you have a line, the tangent slope is that same slope. So the line is just, its slope is the derivative. That's its slope. E to the x, its derivative is e to the x. And for another power, b to the x, its derivative is b to the x natural log of b. Where does that come from? It comes from the formula and the limits, and we can look at those another time. But for right now, these are the rules we're going to use. It may not seem like a lot, 6 rules, but it gives us a whole lot of things to work with. For example, with these powers, sums and numbers multiplied, you can take the derivative of any polynomial. Or in fact, because, we don't have division. When we learn division, then we can do every rational function. But let's take a look at some examples. So, what is the derivative of x cubed plus x squared plus 3x plus 4? Well, this symbol, by the way, means what is the derivative of. It's the same thing as the prime afterwards. This is the Leibniz notation, this is the Newton notation, because they both kind of worked together. Well, actually, not together, but at the same time. And they developed their own little schools of how to take derivatives. This one and this one stayed for over 100 years separate. And now we use them both. I'm going to give you some seconds, actually, as long as you want. You can hit a pause. I'll give you 2 seconds to try these out, and then we'll go over them. Okay, so hopefully you've tried them out. What do the rules say? Well, the rules say that you can split apart a derivative at a plus sign and take the derivative of each piece. Then the derivative of this x cubed is going to be 3x squared plus the derivative of x squared is going to be 2x to the first. I'm not going to bother writing the 1. And then this all together is a line. Its derivative is 3. Hopefully you got 3x squared plus 2x plus 3. That's how it works. It's actually usually about that simple. How about this one? This one, we have to think about it. Square root of x is x to a power. So this is actually x to a certain power, and the power is 1/2. So we can take the derivative and get 1/2 x to the minus 1/2. Why minus? Because we're subtracting 1 from that. Now minus powers, if you don't like this form, this is right, but if you don't like this form, the minus means it's on the bottom, and we can rewrite this as 1 over 2 square root of x. How about this one? This shows where the symbols are makes a difference. The derivative of e to the x is e to the x, because the x is in the exponent. But x to the e, the x is in the base. This is a power rule. Notice, the two pieces do very, very different things. And then lastly, this one. It doesn't look like it works at all. But again, this is x to a power. What power is this? This is x to the minus 2. So the derivative is going to be minus 2 x to the I'm going to write it out formally. Minus 2 subtract 1. Because if you subtract 1 in your head, from minus 2 you might get minus 1. That's wrong. But minus 2 subtract 1 is x to the minus 3. Or you could rewrite this as minus 2 over x cubed. There you go. There are some examples. Let's do one more example, though, with a tangent line. So here's a function. It's a polynomial. I'm going to find the line tangent to x cubed minus x squared plus 5x minus 7 at x equals 1. Why x equals 1? Because it's relatively easy to compute. So how do you find a tangent line? A tangent line needs a tangent slope, first off. So what is the tangent slope? Well, the tangent slope comes from the derivative. So we take the derivative. Take the derivative of that, minus the derivative of that, plus the derivative of all of this. This 5x minus 7 is just 5. That's the derivative. Actually, it's a function if you look at it. But it's not actually the slope, because that's a formula. The slope is a number. So what we do is we plug in this 1. Plug it in for the x's. 3 minus 2 plus 5 is 6. So the slope is 6. So how do you find the tangent line? Y equals 6x plus, well, plus something. And we just have to figure out what that something is. And how do you do this? You do it with a 1 for x. And what do you use for y? Well, we're using the base point right here. And hopefully you can see it's about minus 2. Maybe I drew it a little off. But we can plug it in. 1 minus 1, that's 0, plus 5 minus 2 is minus 2. So when x is 1, right there, y is minus 2. That point is on our line. That point plus the slope is enough for us to solve. Minus 2 is 6 plus what? Well, if you think about it, do a little bit of moving around, that's minus 8. So our line is y equals 6x minus 8. There you have it. There are lots and lots of ways you can use the basic rules. Some of them are messier. For example, here's another one. What's the derivative of, say, x to the 1.8? That's a little ugly. But what is it? It's just the power rule. It's not a whole number, but it doesn't matter. 1.8x to the 0.8. Why 0.8? Because we're subtracting 1. And you can do a whole bunch of things. Try them out. Until next time, this is Dr. Jed.